Hey guys, okay, so last video here, and before we take a look at our notes, which I have pulled up here in a second, I wanted to show you this kind of cool video thing of what it means to actually revolve a two-dimensional surface around an axis, creating three dimensions. So, best way to do that is to use this little visual aid here. So for example, if you have a rectangle here and you were to, so starting off it's two-dimensional, but then you were to actually rotate it around in space, it would create a three-dimensional object. Okay, so let's see what happens when we rotate it around the y-axis. Okay, watch. Okay, so do you see what's happening? What kind of shape do we have now? That's right, it's a cylinder. When you rotate a flat two-dimensional rectangle around an axis, it's always going to create a cylinder. Okay. What do you think is going to happen if I rotate a triangle around an axis? Oh, this is another rectangle. Sorry, let me find my triangle one. Okay, we'll look at those later. Let me go back. Here we go. Triangle. All right. Ooh. So as you can see, that is creating a cone. When you're rotating a triangle, in this case it was a isosceles or equilateral triangle, could have been a right triangle, that would create a cone. Okay, so you can look at some other things. This is a triangle rotated, but it's rotating along the base of the triangle. So that's going to create two cones. What else? These are some cool ones. Ooh, hold on, too far. This creates another cylinder here. So you have, again, rectangles rotated around are going to create cylinders. Dun, dun, dun. Okay. And then I wanted to look at what this next one was because it looked cool, but I don't know what it's going to be. Oh, yeah. So you're rotating another rectangle, but now instead of rotating along one of its sides like this, you're going to rotate it around this diagonal, where it's diagonal to the axis. Skip a little bit there. That's crazy. So it's kind of like these two double cones that are overlapping each other. It looks like a little weird dreidel thing. I don't know. Yeah. And then guess what happens when you do that to a circle? That becomes a sphere. All right. So anyway, super cool, fun stuff. Let's go to our notes. Okay. So as I said, when you rotate or revolve, it's another word they use for that, but either way, when you rotate a rectangle around an axis, you're going to create a cylinder. When you rotate a triangle around an axis, you're going to create a cone. Okay, so let me show you what that's going to look like here. It's going to be, you're going to have to do a little bit of fun drawing here. So we're going to do this example together here. It says, find the volume of the solid if you revolve it around the y-axis. So we identify, okay, that's this one here, so my y-axis. So the steps to kind of drawing this out are going to be, imagine that you just take that triangle and flip it over across wherever you're rotating. So I'm going to rotate across or around the y-axis. So my first step would be drawing a reflected triangle like so. But again, you're imagining it's in this three-dimensional space, okay? And so I'm going to add in a curved little bottom here. Whoops, let me make sure that's a little bit better. Doesn't be perfect. And then I'm going to add in a little dashed line back here to show you that it gives it that depth, okay? And so that right there is a cone, right? We have a cone with a radius of 1, 2, 3, 4, and a height of So you want to count it's from this 3 all the way up to this 3, -3 to 3, so that's going to be a height of 6. Okay, so then we just use the formula for volume of a cone, which is 1/3 pi r squared times the height. Easy peasy. Isn't that cool? So all we do is just rotate that around the y-axis. Okay, 1/3 pi times 4 squared times 6. So that's going to be 16 times 6, which is going to be that's 32 pi units cubed, because we don't have centimeters or inches or anything like that. Okay, so that's in terms of pi. We'll just leave it like that. That make sense? So we're just rotating that around. If I had something like the cylinder here, or you would have a rectangle originally, you rotate that around, and that's going to create this cylinder, right? Where this is your height and your radius is here. Okay? Or if I were to rotate this one, for example, around the y-axis, then it would become, it would also be a cylinder, but instead of that other one, it would be a cylinder that looks like this. Whoops, drop the top and the top. So it would be this really like long, skinny but fat cylinder if I rotated that around the y-axis. Okay. All right. And you can imagine other things that would happen, like this one here would be rotated around the y-axis, would be super funky looking. So you'd have this here and here. So what you'd have there is it's like a cylinder. So this part is all cylinder, but then it's got this cone part. Let me do that in gray. That's kind of carved out of it. So this part doesn't exist, and it's only that kind of cylinder with a cone carved out of it shape. So that's a fun one. But you'll just be doing normal like cylinders and cones, pretty sure. Yeah, until you get to calculus, of course. So there you go. You just did a pre-calculus example there, finding the volume of a rotated two-dimensional figure. Great job. All right, so that ends our lesson today. If you have questions, as you know, email me or please join me in our live tutoring session for whatever period you're in. Okay? Hope you guys are doing well. I really miss your faces. You should really join me in the live sessions, at least for like the first couple minutes. Just say hi, and I'll say hi, and then you can keep working. Remember, you want to do these videos beforehand and try to work on the Pearson ahead of time as well. That way you can ask me questions on the homework and I can help you during the live sessions. Or if you'd rather, you can work on the Pearson during your scheduled class time, and that way I can help you in real time. And then the quiz will be on GradeCam again. Okay? All right. Bye, guys. Miss you.